Honor Chem students, Mrs. Snyder here. I want to give you just a brief rundown about today's lessons and some important things to pay attention to when you're understanding the difference between a strong acid and a weak acid. Kind of taken off of what we learned in the earlier lesson, here you have a picture again of a strong acid which is completely dissociating into the A or H plus ion and the A minus ion. Do you notice that there is absolutely no HA here? That's why it's a strong acid. Strong acids by definition mean that they completely dissociate. So that means you're going to break up into 100% H plus and A minus, okay? A weak acid, on the other hand, which we have represented here by HB, stays together and only a small portion dissociates, okay? So when we look at a strong acid and we look at the equation of what happens with a strong acid, we will notice that here you've got your HA completely dissociating. There's hardly, here I'm having HCl as my example. This could be HCl up here. A, as we've mentioned before, is just a generic symbol for anion. And here, so we have hardly any HCl, and you'll notice that we have ever so small the arrow going backwards. We say that a strong acid dissociates nearly completely or almost completely ionizes. All of that means the same thing. So you have high concentrations of H plus or H3O plus and high concentrations of A minus as we're representing here. Okay, so with strong acids, we say that there's high concentration of products, very, 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 almost zero, almost nearly zero concentrations of reactants. So we say that the equilibrium lies to the right. So for a strong acid, we say that the equilibrium lies far to the right and that it favors products. Okay? So here you're going to read about the equilibrium, a special KEQ called AKA. All right, that's just a special KEQ for an acid. And if you take a look at that, there would be no water because water, even though it's not written here, is in the liquid state. Remember, you can only put aqueous and gaseous species. So the KEQ or the Ka is written, and if you look at that, these concentrations would be high. This would be almost zero, and so that Ka is very, very large. And here's again something we learned earlier in this unit about equilibrium and what does Ka remember, or KEQ mean, or Ka now mean. Remember that if you have something that's very large over something that's very small, you're going to have a value that's greater than 1, and that means that products are favored. Okay? When you look at a weak acid, and here's my example of weak acid, which would be HF, most of that HF stays together and only a small portion will dissociate. So look at the arrows here for this generic equation. Notice that it's favoring reactants. Okay? So that means they have low concentrations of the H and the conjugate, and you have high concentrations of the reactants. So low concentrations of products, high concentration of the reactants. Look at the arrows. We'll notice that the arrow is really going more towards the reactants. So for weak acids, we say that the equilibrium lies to the left and reactants are favored. Okay, so here we would be writing the weak acid for the Ka value, I should say, for that weak acid, and that is called, that would have a Ka value less than 1. Okay, now the other thing to think about is what is the conjugate of this. So remember that this is the conjugate of this acid. This is called the conjugate base of the strong acid, if you remember from your Bronsted-Lowry theory thing. So for a strong acid, and we look at this being a strong acid, this would be its conjugate base. We say that the conjugate base is weak because it does not want to go back and make HA, okay? And then also here, for a weak acid, okay, this would be the conjugate. We say that the conjugate acid, or I'm sorry, the conjugate base for a weak acid is strong, okay? So a weak acid produces a strong conjugate base, and a strong acid produces a weak conjugate base. So you guys can read through that, and that's an important concept to know as well. All right, I hope this helps, and good luck.